Okay, so in this video, I'm going to show you how to use the concept of chain rule when you have a function w, which is a function of two variables x and y, whereas x and y are functions of different independent variables. X is a function of s, y is a function of t. So we will write down our general chain rule. We just have to be a little careful. So how I want to write it, I will say if I'm trying to find out del w del s, I will be first finding out del w, and because w is a function of x, I will say del w del x times del x del s. And as you can recall, I will now go ahead and say that I'm going to derive w with respect to y, so del w del y times del y del s. Now, why I cannot say the left-hand side, like we have said in the previous situation, is equal to a total derivative? Well, if you think of it carefully, w is a function of both x and y, x is a function of s, and y is a function of t. So when you are trying to take the derivative of w with respect to s, you are only getting the partial change of w with respect to the s changes. Similarly, if you are trying to understand what is del w del t, then that is going to be del w del x times del x del t plus del w del y times del y del t. So there is absolutely no change in this problem since we have done the last problem, except the left-hand side in the last problem was a total derivative with respect to t, because both of the variables x and y were independent functions of only one variable t. Since I have more than one variable, the left-hand side in this new problem cannot be a total derivative, has to be partial as well. But we are only interested in the partial derivative, so that should be good enough for us. So let's start talking about del w del s in context of our problem. So del w del s, as I said, first do the derivative with respect to x. So derivative of y cube is 0, but derivative of minus 6x squared y is going to be minus 12 and xy. Then don't forget your del x del s, which is going to be e to the power s. That's nice. And then the next term is plus. Now I'm going to do del w del y, and I will get 3y squared, and I will get minus 6x squared as the derivative with respect to y, and I'm going to multiply this thing by del y del s. And remember, del y del s, because y is not a function of s, is going to be 0. Which means your term is going to be minus 12. Think about x, x is e to the power s. Think about y, y is e to the power t, times, you had this e to the power s previously, and then that is your final answer once you have combined the e to the power s terms. So you get minus 12 e to the power, see I have two s's and one t, so I'm going to write e to the power 2s plus t. So that will be your answer, minus 12 e to the power 2s plus t. How about del w del t? So pretty similar treatment of our function. So I want to do del w del t. So I do del w del x, and that is exactly the same thing. It's minus 12xy. But this time you are multiplying that by del x del t. But x is not a function of t. So this derivative is 0 plus, then you do del w del y, which is 3y squared minus 6x squared times del y del t, which this time is going to be e to the power t. And then finally we are going to interpret x and y in terms of their definition. So this is minus 12 e to the power s times e to the power t times 0. I didn't actually have to do this thing because multiplying 0 will eventually make this term 0, plus 3y squared. So I will say 3. Remember, y is e to the power t, so I do e to the power t squared, minus 6x squared, so e to the power s squared. All of that is going to be multiplied by e to the power t. Okay, so I get 3 e to the power 2t minus 6 e to the power 2s multiplied by e to the power t. So you distribute, you get e to the power 3t, 2t plus t, and then you get minus 6e to the power 2s plus t. And that should be your answer for the partial. So you will say 3e to the power 3t minus 6e to the power 2s plus t is my partial derivative. And finally, we're going to evaluate both of these partials at s equal to -3 and t equal to 6. So for the first one, you will get -12 e to the power 2 times -3 plus t, which itself is 6. So if I look at the power is already equal to -6 plus 6 equal to 0. E to the power 0 is 1, so I get -12. Whereas the second one, if I do 3e to the power 3 times, t is 6, and minus 6e to the power 2 times s, which is -3 plus 6, as we have done in the previous one. And this one is going to be 3e to the power 18 minus 6 times e to the power 0, so minus 6. So these are my final answer to the question, which is describing finding the partial derivative of w when w is a function of two variables x and y, x is a function of s, and y is a function of t. All right, so let's go to next page and try to work this problem. It is, as you can see, pretty similar. This time your x and s both are functions of both variables s and t, whereas z is a function of s and t as well, and w is a function of all three of them. And I'm interested in learning how much is del w del s, del w del t. And eventually, we're going to find del w del s and del w del t by converting w to a function of s and t before differentiating. So let's first do the first way using chain rule. So as usual, what I'm going to write, I'm going to first say, since w is a function of three variables and all three of these variables are function of two variables, s and t, we'll write the chain rule as follows. Del w, if I'm interested in learning del s, then you do the derivative of w with respect to x, multiply del x del s, plus del w del y del s, plus del w del z del s. Of course, the other one is finding del w del t, and finding del w del t will be pretty similar, del w del x, except this time you are deriving your variable x with respect to the variable t, plus del w del y, and you derive your variable y with respect to t, plus del w del z, and you derive the variable z with respect to t. So let's work these problems out. So first and foremost, I'm interested in knowing del w del s. So this is the formula. I look at my del w del x, and it is going to be y times z. I'm multiplying it by del x del s, and the derivative, as you can imagine, is going to be just 1. Then you have del w del y, which is going to be x times z, so plus x times z, times, now I'm taking the derivative of y with respect to s, which is 1 as well, and finally I will do del w del z, which is xy, take the derivative of z with respect to s, and you get t squared. And as we have talked about so many other times, your objective is to write down y, z, and x in terms of s and t. So we'll say del w del s, remember y is s minus 4t, then you multiply that by z, and z is s times t squared, and then I multiplied 1, and so I'm going to leave it there, then plus x times z, x is s plus 4t, and I multiply it by z, which is st squared times 1, finally x times y, so you do s plus 4t times s minus 4t, and you multiply that by t squared. I believe I can simplify this thing. So If I distribute its st squared, I get s squared t squared minus 4 times st to the power 3. Similarly, I get s squared t squared plus 4 times st to the power 3 plus s squared t squared, and then you get minus 16 t to the power 3. So these are all the terms that I'm expecting once I have FOILed and distributed everything. What else? Well, you can combine terms. As you can see, I have 3s squared t squared minus 4st cubed plus 4st cubed will cancel each other, and I will have minus 16t cubed. So that should be the first answer. I have to check my work, and in course of finishing this problem, we will be able to check the work already. So I'm going to leave this one as the answer for the time being and proceed to the next problem. Okay? So you are doing del W del T. You already know these three derivatives. They're going to be the same. First one is YZ, and del X del T is going to be positive 4. Del W del Y, that's going to be XZ. And del Y del T is going to be negative 4. And then I have plus, this is going to be XY, and then del Z del T is going to be 2ST. Change everything in terms of T and S. So we will say Y, which was S minus 4T times ST squared times 4, plus S plus 4T for X. Z is st squared times negative 4 plus s plus 4t times s minus 4t times 2st, and then simplify these terms. So again, distribute, you get s squared times t squared minus, and that should be a 4 as well, 4s squared t squared minus 16st cubed plus s squared t squared, and this time they are going to be minuses, so we'll say minus 4 s squared t squared minus 16 s t cubed. Then I'm going to get s squared times 2st, so I will say plus 2 s cubed t, and I have negative 16t squared, so I'll get minus 32 s t to the power 3. And let's see whether we can simplify some of the terms. Well, I see that 4s squared t squared negative 4s squared t squared are going to be cancelled. I will also have, as I can see, 2s to the power 3t, and then I have minus 16, and I have minus 32, so that's a total of minus 64 st cubed. And I'm very suspicious that I have made a calculation mistake, but again, I'm not willing to stop. I'm going to write this answer down and then do the other way of finding these partial derivatives and check whether I have done it right or not. So 2s cubed t minus, and you have 64 st cubed. That is possibly the answer for del W del T. So the second process is requiring you to find del W del S and del W del T, but it is saying before you start taking the derivative, change x, y, and z in terms of S and T. So we'll do that. We'll say W, which was x times y times z, should be equal to S plus 4t for x, S minus 4t for y, and then st squared for z. So I get a squared minus 16t squared times st squared, which is s cubed t squared minus 16 st to the power 4. And remember what I'm trying to find. Del W del S. Derivative partially with respect to s. So you get 3 s squared t squared minus 16 t to the power 4. Did we get that last time? Let's check. So Yeah, we did. I mean, that should be t cubed, and I have written down, so this thing is not matching, and I think I have already found out what is the mistake. So 4t times negative 4t is 16t squared times t squared, that should be a t to the power 4. So this is why I did not want to erase all of my work, because I knew that I will be able to check my work. So this power here is going to be 4. Let me rewrite that thing so that when you look at the completed lecture, you don't get confused. So this is, as we said, will be 16t to the power 4, and that should be s minus 4t. So that is good. I just have to change this one here, make it 16t to the power 4. So far so good. We'll go back, and the only other thing that we're going to find out is del w, del t. So when I'm finding del w, del t, you are doing the derivative of the same expression with respect to t. So you get 2s cubed t squared minus 16 times 4 is 64 s t cubed. So is this what we got in the other way? And 2s cubed t minus 64 s t cubed. So we're good. And that concludes answering this question. So let's go to page number 6 and see what we have there. So this is again, as you can see, we have a function cosine xy plus sine yz plus wz equal to 16, and I want to differentiate implicitly to find the first partial derivative of w for all x, y, and z. So I'm going to work it out. So we will start deriving both sides with respect to x for finding del w del x. So what we will do, derivative of cosine xy is minus sine of xy, then you do the derivative of the inside, just don't forget to do the partial derivative, which is just going to be times y. xy's derivative with respect to x is y. Okay, do the same thing for the next one. See, this term doesn't have any x, so derivative is 0. Then you have w times z. Well, I'm going to find the derivative of w with respect to x, which is del w del x times z. Then product rule tells me I'm going to take the derivative of z and multiply with w. But derivative of z with respect to x, if I write, is del z del x. And I want you to understand z is independent of x. So del z del x will be equal to 0. So I get to say that this is equal to minus sine times the sine of xy times y, 0 I'm not writing, plus del w del x times z plus w times 0. Now remember, this is just the left hand side. If you think of the right hand side, that was 16 constant, so derivative will be eventually 0. Now this is an expression in terms of x, y, and del w del x, and I'm going to solve it for del w del x. How do I do that? I first write del w del x times z is equal to, now w times 0 is going to be 0, I'm not caring about that. This term, you will add it on both sides and get y times sine of xy on the other side. Remember, you were trying to find del w del x, so divide both sides by z, and I get del w del x is equal to y sine of xy divided by z, and that should be my answer. Y sine of xy divided by z. Okay, I'm going to find del w del y now. So pretty similar process. Just remember, x, y, z are all three of the independent variables. The only dependent variable is w. So derive cosine xy with respect to y, you get minus sine xy. Derivative of xy with respect to y is x. Sine yz will give you cosine of yz times derivative of yz with respect to y is z. And then w times z, similarly, you will say this is del w del y times z plus w times del z del y. So I'm writing this term, but I don't have to write it as I know both y and z are independent variables, so partial of z with respect to y is eventually going to be 0. This is left hand side, right hand side is the derivative of 16, so that is 0. So what we are going to have, minus x sine of xy plus z times cosine of yz plus del w del y times z equal to 0. We are solving for del w del y. So you will first say del w del y times z is equal to x sine xy minus z cosine yz. Then divide both sides by z. So you get del w del y is equal to x sine xy minus z cosine yz all over z. And that should be the answer to del w del y. I'm not going to put that down in that small box. We'll not be able to fit it in there. Okay, so your third one is going to be finding the partial derivative with respect to z. So I'm going to again look at the same function cosine xy and see it is not going to have any derivative with respect to z because z is absent in the first term. So we'll start with 0. And then plus you have sine of yz. So you will get cosine of yz times derivative of yz with respect to z is y. And then you have z times w. So you will get plus del w del z times z plus w times, eventually we are supposed to get del z, but del z is derivative of z with respect to z, which should be 1, whereas the right hand side is still equal to 0. So what I have cosine of yz multiplied by y plus z del w del z plus w equal to 0. And I want to know how much is del w del z. So z times del w del z is equal to negative w minus y cosine of yz. Divide both sides by z, you get del w del z is equal to minus w minus y cosine of yz all over z. And this is called implicit derivative involving partial differentiation. Okay, so